So thank you so much, everybody, for joining early. I think it is important to start early on time. Last time I had some technical issues. That's why we did not start sharp at the time. But today, for actually Sebastian, Adrian, who is here, told me, you know what, let's join earlier. So just to make sure you don't have any trouble at all. Unfortunately, today I didn't have any trouble. So not sure what might have happened, but it is what it is. Can you hear me loud and clear by chance? Because sometimes my headset may behave weird. But nice.
Yes.
Thank you very much. Thank you for confirming. Thank you very much. Appreciate it.
Where are you for right now? In Mexico City?
No, actually, I live in Guadalajara.
Right.
Yeah, I live in Guadalajara. So if you by any chance you come by, just let me know and we can have a cup of coffee or so and just talk. But yeah, I'm in Guadalajara, actually nearby the campus, fortunately. Right. So each time I need to go face to face, I just need to drive 10 minutes from here. So it's not a big deal.
The campus is in Zapopan?
Yes, it is. It is. Yeah, right. It's Avenida Aviación and Avenida Santa Margarita, something like that. And it's kind of nearby here. Okay. Okay, so thank you so much for your questions. Well, after being at the top of the hour, let's get it started. So today, you'll guess what? You're gonna have a little bit more exposure to much cooler things and hopefully more useful things, in the sense that from now onwards, it's gonna be more practice than anything. Today, I'll give you a little bit of theory, of course, because it's always important to give you some background about the methodologies and things that we're gonna see today. But today we will focus into two particular kinds of regressions. Actually, yeah, we will focus in linear regression, which actually you may name it forecast, perhaps. Although there are some forecasts which are not linear, right? So that is usually called polynomial regression. Polynomial regression is something that we'll take a look to next class. Actually, if today we have time, I would like to take advantage to take a look to the three of them. I mean, it's not part of the plan, but perhaps we can take a little bit more advantage. So, and perhaps next class focused on other algorithms that are planned as part of that class. But let's get it started, right? So when we are talking about a regression is nothing but a process. We have, if you're actually, let me use my super powerful paintbrush skills. I think that would be much more helpful. Let's go paintbrush, here we go. Okay, if you remember, we have something, actually first I'll use Excel better. Let me open Excel. Actually, as I mentioned to you before, well, we have a Cartesian quadrant, right? So we have the quadrant here, the first one, right? And pretty much we have two variables. Can you please remind me how are those called? Or what's the most common name for those variables? Do you remember?
X and Y?
Yes. However, it can be any variable. However, one of them is called dependent and the other one is called independent. Do you remember that?
Yes.
Yes.
Beautiful. So usually when we talk about X and Y, thank you so much for that comment. When we have X and Y, usually X is the independent variable and Y is the dependent variable. Do you remember why?
The value of one, if the value of the independent changes, it will change the value of the dependent.
You are amazing. You are totally right. Exactly, that's the point about this. Yes, exactly. And for instance, in this case, let's say we have 1, 2, 3, 4, 5, 6, 7, blah, 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 right? So let's say that X, it's equal to each one of those values. So X is gonna be the independent variable. By independent variable, we means that it is what it is, right? It stores that value. So X cannot be changed. Example, or ages, right? Now at this point, I mean, next year, of course, in our next birthday, our age is gonna change, of course, right? Unfortunately, does not remain the age that we're at. So it's gonna change. But up to this point, right? However, let me give you an example. The degree, I mean, no, actually it's a bad example. Let me rethink it another one.
Probably on the age, the constant will be the year you were born in, and then your age will be the dependent across the time.
That's a very good one. However, as per being continuous cannot be taken as dependent because it's independent because it doesn't depend on anything. But let me give another example. Right? So let's use this one. For instance, we got X here, which is between 1 and 29 and 19, right? However, Y can have a formula that says, you know what? Whatever X has, let's multiply it by what number do you want?
6.
6. There you go. So what it means that Y by its own cannot exist without X, right? Why? Because if X does not exist, what is going to happen with Y? It's going to disappear, right? It's totally dependent of the existence of X, which can be, the equivalence could be like something like this, right? Like Y is equal to X multiplied by 3. That's a formula that we established, correct? What it means that as more X changes, Y is gonna change 3 times more. That's pretty much the logic behind the scenes about this, right? So if we replicate this, so what it means that if X is 2, what is gonna be Y? Actually, this is, wait a second, something is not right here. But we said it's 6, right? I'm sorry, it's 6. Made a mistake. We said it's 6, right? So what it means that only once X and Y are exactly the same, correct? No, I'm sorry. It never happens, right? Because here X is 1, Y is 6, right? It's nature. What is gonna happen when X is 2? Multiplied by 6, it will be 12, correct? So what is going to happen when X is equal to 3? What is going to happen with Y?
It will be
18.
18, exactly. And so on and so forth, right? When X is equal to 4, so it's going to be 24 and so on and so forth. So there's X depends on Y. Y depends on X all the time, right? That's why we call it dependency. Let me give you another example. The car depends on gasoline, right? Without gasoline, your car cannot turn on. It's a direct dependency, right? Another thing, if you want the water to flow, you need to have water pressure, no? If you don't have water pressure, the water will not come out of the sink. So those are kind of the ideas that you may bear in mind about dependency of the variables, right? Another example, if you want to drive, you depend on a driver license. Or what if, let me give you another example. So the amount of water and the speed of the water depends on the pressure when you open the water. As more you open the sink, right? As more water, as more pressure you would get. It's kind of, let's think that it's kind of a sink, something like that, right? Like the X is nothing but the sink itself, and the water is the Y. The amount of water depends on how much we open it. It's something similar to this. So if we bear in mind that here we have X and here we have Y, right? We said that Y is dependent on X in that relationship. So we said Y is equal to X x times 6, right? X times 6. And so what is going to happen? So here, if we are talking about a regression and understanding this behavior, it's going to be a line. Pretty much it's going to be a line. So this line, what is going to be? If we bear in mind that this is going to be x equal, what a horrible, all my skills today are not as good as I thought. So anyways, it is what it is. So let's say that x, here's y. What is going to happen with, I'm sorry, x is equal to 1. What is going to happen with y? How much is that going to be?
Gonna be 6.
It's going to be 6, exactly. However, both are equally when those are in 0, correct? Those start in 0. That is a nature about the formula that we established, though. So this is 2, 3, 4, 5, 6. Here we go. So the dot will be pretty much, actually, let's forget about the dot, and we will put a line. So this line, it has certain particularities, right? The first one is the direction. It has a direction, which is pretty much this one, right? This is the direction of that particular vector. We may say vector, why not? Because at the end of the day, it has a direction and it has dimensions, right? So pretty much we can see this is called a trend. This is a trend, or it can be what's the direction, the trend, and so on and so forth. So we need to bear in mind that each vector has this situation. However, what if it were the other way around? What if it were negative? What if it were negative, right? It would be a totally different behavior. Like for instance, in this case, if x were negative, we would have a different behavior. It would go the other way around. It would start by minus 6, and it would go at the other direction, which would be something like this, right? So that's why it's important to understand what's the trend for that particular phenomena, for that particular vector. It's important to bear in mind that each and one of the vectors have a direction, and here the direction is important. It's not the same earning money than losing money. It's something very important to bear in mind. Okay, crystal clear so far? And if we bear in mind that, and a regression here would be, if it were linear, would be something like this. It would go above and beyond, following the same structure, right? Okay. So clear so far? Questions? Okay. Guillermo, can you give me an example of a linear behavior in real life? Guillermo Renzo? I know we have both. We have two.
A linear regression in real life.
No, a linear behavior in general.
Oh, linear behavior. Maybe we can say about the sales of a product. If we sell more, we have more products. We have more sales.
Yeah. However, it was a tricky question, honestly. It wasn't my intention to expose you. Sorry about that, Guillermo. But there's nothing linear in this world. Nothing is linear in this world. Why do we, you may wonder, then why do we use linear regression? Well, each time that you perform an analysis, you need to start by the simplest, always. So the simplest one is a linear regression. There's no simpler model that you can use but a linear regression. That's why first, Guillermo, you need to start with something linear, because it's easier to visualize, it's easier to understand, because this trend that was really, really high, right? 6 points against 1 is a huge difference. So it gives us an idea about how is something behaving, which is really important and really interesting, right? So that's why we start with a linear regression, because it will help us to identify what's a specific trend, what's the behavior, and also we can identify that there's certain dependency between or among the different parties that are involved there. Here we only have X and Y, right? Nevertheless, perhaps in other options or in the future, we can have more than that. We can have either more variables or something else involved in the future of something. Because when we use actually, I'll rename this. When we use the, prescriptive, descriptive, and we try to anticipate something, it's something we try to anticipate to the future. We try to predict the future. That's why these models are so powerful, because it reads between the lines. It reads something that is hidden in the data that we cannot kind of straightforward identify. It identifies those patterns. Let us know, guess what, there? Nothing is linear, but it may be kind of linear, and I'm gonna tell you what is gonna happen. So, you know what? I was about to keep on going with this mumble jumble, but what if I explain you, but in real world, right? So I think it would be way better. So let's, oh, spoiler alert. What's going on here? Come on, Fer, spoiler alert. It is not good. It is not good. Anyways, you already know the answer. That is not cool. But let me explain you, right? So when we are talking about the linear regression, you remember that we have two types of models, right? Supervised and unsupervised, correct? Do you remember that I mentioned that? No, you don't remember? Okay. When talking about predictions, or let me use the buzzword, the machine learning world, we have two types of models, supervised and unsupervised. If you remember, the supervised ones is when you have labeled data. Do you remember that statement? Labeled data? You remember that? And there's another interesting fact around predictions. You need historical records to anticipate something. That's true for supervised models. In other words, if you want to perform a regression, what do you need to have? What do you need to have? So for instance, here, I'm gonna use this example. Let's imagine that you work into a company, and all of us who actually work in a company have or tables, right? Or budget. So based on our budget, if we hire someone with a certain level of experience and also some certain background to cover certain role, we offer a specific amount of wages, right? Depending upon the experience, depending upon the demand of the role, depending upon other factors, we offer certain wages, correct? And actually, all of us who actually have a job, we are getting certain wages due to the level or experience or level of maturity, and also our efficiency to do our job, right? That's pretty much. So here, we are not taking into consideration too many factors, only years of experience, right? So based on our historical records, we can say that someone who actually has 1.1 years of experience earns around $40,000 a year, right? So one who actually has 3 years of experience earns around $60,000 a year. Someone who actually has 5 years of experience earns around $66,000, and so on and so forth. Crystal clear? So good so far? Right?
Yes.
Awesome. So the idea here is kind of to work with the truth or bluff, in the sense that, have you heard the statement truth or bluff? Let me give you an example. You ask someone, you are interviewing someone, and you, let's say it's a semi-junior person actually have worked for 3 years in a company, and you ask them, how much do you want to earn? How much you are earning now, and how much do you want to earn? Sometimes it's a fair question, sometimes, right? And they may tell you, you know what? I want to earn $60,000. And maybe you don't, top of mind, you don't remember that situation, so you can use the truth or bluff of the situation. What is going to happen? So you take a look to this tabular view, right? And you say, okay, he has 3 years of experience. Let's take a look. Okay, it's a bluff. It's a bluff, right? So those are kind of the things that it may help you. I mean, this is the simplest, I told you. I'm going to show you some more sophisticated models that can help you to anticipate something, even taking into account other factors. So, but up to this point, we are starting with the simplest one. Okay, now, what if we return back to our code? Okay, here, so this is the data set that we're going to use, which is pretty much 2 columns. years of experience and the salary that your company offers based on years of experience. Of course, it can be a range. Of course, in reality, are ranges of starting and ending point. And usually between that range, it's something that you can offer. Above and beyond that, it may depend whether it's a hard skill that you're looking for and it's a person or a situation where you need to fulfill a position is where actually you can invest more or risk a little bit more with that person, right? Okay. Okay. Actually, the code that I gave you is pretty well explained. If you can see, I include the hash and include some explanation around what is happening there. However, don't worry, I'm going to explain it. Sure? Okay. First, the library that we need is CA tools. CA tools, which is here. Install packages. For me, it's already installed, right? And we invoke CA tools. The CA tools contains pretty much the logic for the simplest models in regression, right? So what happens here is that this library contains already all the logic behind the scenes to create the relationship between the two variables and create this behavior based on how is one changing against the other, right? What is going to happen? Okay, we are going to use this set seed 1, 2, 3. The set seed is nothing but in order to give a real world prediction, because one thing is forcing something to behave in one fashion, right? Let me give you an example. When you are driving your car, you can force your car by pressing the accelerator to go at certain kilometers per hour, correct? I mean, you can push all the way through and you have a Tesla, simply you can go really, really fast, right? However, there are other situations where you actually need to anticipate what is going to happen, but closest to reality. There's something that we call overfitting. That's why, I'll explain the overfitting in a moment. You really want the model to predict something, and the prediction will not be 100% perfect. Else, if it were 100%, it's not a prediction. You are either reading minds or you can really see the future. A prediction is nothing but you want the model to behave in certain fashion that can give you the closest value as possible with a certain level of error, right? As any prediction. Okay. Now, here what we are doing with seed, it is taking random values out of your data. So what is going to happen? So once that we set the seed, what is going to happen? It's going to take your data set and it will take random values out of that. For instance, we'll take, for instance, the 1.3 years, and it will say, okay, for the 3 years, 1 year and 3 months, 1 year and 3 months, what is going to happen? Okay, the algorithm says, okay, this person earns 46,000, right? It will take another random value. Let's say 5.1, 5.1, 5.1, and it will say, okay, 5.1, that person earns $66,000. So what is the algorithm going to do? It will take some other random values. Let's take another one. Let's take 8.7, and that person earns $809,000, right? So that's exactly what is it doing. The algorithm is taking random values in order to understand what's the relationship or the pattern around that, right? What happens? Well, it takes different statistic values. For instance, the mean, it takes the standard deviation, it takes so many factors out of that to understand how is it behaving, right? One example, it can be a division, right? Between divided by the year. So to understand how much would be per year, right? So as we can see here, as more you grow or as more mature, as less is the increase. Why? Because there's no infinite money, right? So we can say that it's not linear, right? As you can see the relationship. What other factors we can use, for instance, the difference between this and this, right? to understand what's the difference. So it takes many, many different factors that can it happens behind the scenes. You never notice that all these factors are happening behind the scenes. It takes the standard deviation, the mean, the mode, everything happens behind the scenes in order to understand and describe how is the data increasing or decreasing over the time, right? So based on that is where actually we use the set seated to understand and take random values to describe the entire model. You may wonder, Fair, why doesn't it take all the values? Have you wondered? Why do we take only random? Have you wondered why don't we take all of them? You have not wondered?
To make it more like faster?
Very good question, but very kind of point of view. The first, yeah, in fact, you are right. However, we want the model to learn. When we say overfitting, let me give you an example. It's a good time to talk about overfitting. Let's say that we have this behavior, right? So for instance, we say, okay, between 1 and 2, we have 12, right? I'm sorry, when x is 1, we have y minus 6. When x is 2, y is minus 12, and so on and so forth. So we can anticipate the future, right? But what is gonna happen if by any chance, rather than getting 12, we get minus 11? What if in reality, instead of getting minus 18, I got minus, actually, let me put it even more drastic, 0.9, right? Maybe instead of 18, we get 17.85. As you can see, it's pretty much close, right? But it's not exact prediction. So what we are doing here, the overfitting, and when we train the entire model, let's say instead of taking random values, to let the model know, oh, you know what? Identify that error. If we force the model to behave exactly the same as this one, we can say, you know what? For the 20th, we are forcing to be 120, but maybe it's 117, the real prediction. When we test all of them, we force the model to behave in certain fashion, right? That's why we only take random values to describe the model, not to force it to behave exactly the same in the future. Because perhaps in the future we have 25 rather than having 117. Maybe, I'm sorry, no, this is not the formula. The formula is here. Perhaps it's 170, right? And we are forcing the model to be 150 when actually is 170. We need to let the model understand those patterns and anticipate to the closest, else you are forcing it to behave in the fashion that you want. Crystal clear? It's like, let me give you an example. You are buying stocks from a company. In 1 year, do you have control about how much you are earning when you buy stocks? For instance, if you had invested in Amazon 10 years ago, nowadays you would have 10 times as much as what you want, or as what you invested at that point. So, but did anyone had any idea that actually that was about to happen? No one, because there's a risk that perhaps there's a drop or maybe an increase, right? However, when you perform these kind of predictions, let's say that you anticipated that when you invested $18, you expected now to be $50, but it is not, it is 30, right? It means that you predicted it was about to increase. So what we want to predict is the trend and the closest value to it, not to force it to be in the fashion that we think is not exact, is not kind of exact relationship, right? So what it means, if you want something to behave in some fashion, you don't have control about it. You need to rely on historical records to understand trends and try to anticipate to the closest value as possible, right? So good so far? If it's not clear, please let me know, because this thought this key concept, it's so important for prediction. It's so important for predictions. If someone has a question, please raise your hand. It's important. I know that it's complex because you may wonder, why don't we take all the values and anticipate exactly the same? Because we want the model to learn patterns, not to force the model to follow the rule of those numbers. Questions so far? I'll give 5 more seconds because I know it's a complex concept. I know it. That's why I'm trying to explain it kind of an easy way, in an easy fashion, just to let you understand that, yeah, I know that it's not an easy task. It's not an easy concept because here I'm forcing it to behave linear. Nevertheless, when you are in real world, those do not behave in that fashion. It is not 18. Here is 19.85. Here maybe is minus 26.1, right? So it's not 24, nevertheless, still close to that value, right? So what if we don't keep on going with the regression to give you a better explanation about what's going on, right? So, okay, let's continue with this. With this one, I told you, right? With set seeded, it's gonna take 5 random values out of this, or X number of random values, and in order to understand the behavior. That's what we do here with seeded. For instance, first we declare the method, which is seeded. And afterward, let's take a look about what it is, right? Just to give you an example, what's going on here. So what it took, actually took a length of, I didn't take anything. Why not? Okay, we have not declared. Let me declare the data set. Let's take a look to the data set. Here we go. Afterward, let's invoke the library. Let's set seeded. And let's take a look to the values. So what happens here, it creates an object, which is seed. Up to this point is new, right? But it created this object. With what is going to happen here, it will store the random values that we will require to understand the pattern. So when are we going to use it? Okay, now we will create another object, which is split. I mean, you can name it whatever you want. It can be a regression, any value that any name that you want to give. Here, I called it split. Okay, what is, actually, I'm sorry, the split, what it does. This one, it is going to take a sample out of the entire world of the data set, only 1/3. What it means, only 1/3. That means that out of our entire data set, we have 30 values. How many values is going to take if we say 1/3?
10 of
10.
them.
Exactly. It's going to take 10 values, random values, to understand how is it behaving. And using the seed, it will take those random values and store them in order to understand what's the behavior. So here is where actually we're sampling the data. Here, split, we create the object called split. We use the method sample, and it will take 1/3 of random values out of the entire data set. So what if we take a look to that? Here, then if you can see here, it's called split. Let's look for the split here. As you can see here, it took from out of the 30 values, it took the first one, which is this, right? The 1.1. It took the third value. Those are in order. So it's taking random values to understand how is the regression behaving, right? Okay. Afterward, we will take the training set. The training set is gonna do this. Let me give you an example. Let's say that it takes this example, and it will take 1/3, right? So if we set 10 random values, right? Let's take 10 random values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Let's imagine that out of this world of data, it only took these values. Now it's understanding that there's are certain patterns where, okay, X is related, Y is related to X, and as more X is changing, Y changes as well. That's a first thought that the algorithm does. Now, let's understand if this one is 6, okay, it takes different patterns to understand how is that changing. For instance, it says, okay, from 1 to 3, it changed 12 places, right? Now, the algorithm is taking all of this to understand how is it behaving. In other words, to say, okay, now if I get a 40, based on this pattern, I know that I can apply the same formula, right? So this 40 has a relationship to the entire pattern, which is going to be increasing, and it will give you a similar value, perhaps up to here, that it says, you know what? When you have 40, that means that you will have 200, right? For giving an example. Okay, it's what it does. So let's take a look to the algorithm. So here, what is going to happen? Now, the training set means it's going to take those random values, and now it's going to understand all the patterns that it's driving the values to increase over the time or decrease, depending on the situation, right? And afterward, we will create a test set. The test set is nothing but take all the random values from that universe and prove that is this similar behavior. For instance, this time around, it's gonna take another random values, right? Let's say here, here, and here. So the training test is gonna take this one. Let's say, for instance, this line, and it says, okay, the test set told me that when we have 6 compared with X, that means that it is expected minus 36. And actually, okay, let's test it. Guess what? Is it true? Based on this analysis, it's true. So it is saying, guess what? In this case, you are right. When we use 6 and I test the entire data set, I analyze that actually you got the 36 as you predicted. This is the prediction that is trying to test. But what is going to happen if, for instance, this one, instead of being minus 54, it is minus 50, because it can happen. Now, no model is perfect. This is going to say, okay, guess what? This prediction is not correct. So here you have an error, right? Because every single prediction has a level of error. But if we test the others, for instance, here, it says, okay, here, you're right again. This one is no error. So it's going to take the average error of your entire model, and it's going to say you only failed once. That means that you have a 99% of effectiveness, right? Okay, let's continue with this. So what we are doing here, again, we are taking a sample of 1/3 of data. We are testing and understanding the patterns of that data. Which are the patterns here? Well, the data is increasing over the time, and it has certain relationship between X and Y. That's exactly what it's analyzing, right? Afterward, what it does. Okay, what it does. Actually, did I close it? No, it's here. Afterward, it performs some feature scaling. Do you remember what I told you about scaling? What was scaling? I already explained that. Nope. No volunteer, no one remembers what scaling? Do you remember that I explained you about the map?
Is to adjust the range of features or variables, something like that.
Exactly, but what would be one analogy? For instance, if we talk about in this chart, right? In this chart, we mentioned maybe we have $1 million here. Oh my, I'm sorry, $1,000 here. $2,000 here. $3,000 here. Okay, let me explain you here. Is this something, is this how $1,000 look like? I mean, you see a bunch of dollars, right? I mean, this is not how $1,000 look like. So we are representing the $1,000 in a centimeter. In a centimeter. What it means? That $100 would be what? A millimeter, correct? That's what we call scaling. Based on the area that we have available here, is the values that we will assign to the maximum value and to the minimum value to make it fit in this area. Clear now? Here, we need to represent a $3,000. So we cannot represent it here, right? Unless we see the bunch of money here. So we need to represent it somehow. So in that case, we provide per each and 1 centimeter, per each and 1 millimeter that we have here, it has a graphical representation. Is what we are doing exactly here. We are transforming the amount of dollars into a graphical representation of the same. Okay, let's continue with this. Now, we will use another model. Now we will declare a variable. This time around, I called it regressor. You can call it whatever you want. This one, it's important. It's not important. It's the name that you want to give. Afterward, I will use the linear mode. And what I'm gonna take, okay, out of my data set within, I establish the formula. The formula, I am saying, okay, salary is the dependent or the independent variable?
The dependent.
The dependent. There you go. So first, we put the column, which is the dependent variable. We use this symbol, the virgula, whatever you want to call it, to say salary is dependent of years of experience. This is the relationship. Afterward, you use a comma, and you let the algorithm to use the training set to anticipate any value, to learn and understand what would be the future value for that particular regression. Okay, so let's declare this object, because it's an object, it's not a value yet. So for instance, let's take a look here. Regressor, as you can see here, it created an object with 12 placeholders where it's gonna put the training set. In other words, out of the training set, it took 12 values, trained them, and now those are represented in that particular vector. It's a placeholder of those values. Now, let's take a look. To that. What were the predictions? Okay. So now we have widespread. Let's take a look to widespread. So what happened here? It took new values and is applying the model to understand how is that behaving. As you can see, it is saying, okay, I took random values. Out of those random values, I took 30, and it's anticipating how those are gonna behave in the future. This is already prediction after the learning that it made. Understanding the data, and afterward, it can make any prediction as it wants. Okay, let's keep on going with this. Now, let's analyze the regression that it made. We will use the method summary applied to our object that we declare for the regression. Let's do that. Okay. If we take a look to that, do you remember that I told you, okay, it will use different statistical methods to describe your data, right? So here we go. It is telling you, okay, the minimum value is 7,216.9. The first quartile is 2008.8. The median is 657. The third quartile above is 2,138. And the maximum is 9,367, right? So it's taking statistics out of that. Now, here, this one, it's important. The p-value. The p-value is nothing but, actually, this is not the p-value. I'm sorry. Let me see where's the p-value at. P-value, here we go. Here we go. The p-value is nothing but the level of certainty that your algorithm, I mean, all of them are kind of describe your model. But the p-value as closest to 1, I'm sorry, as closest to 0.05, it means that it has 95% of efficiency, your model. So as smaller as the better, the p-value. And as you can see, this one is really, really, really small. That means that is almost a perfect prediction. Almost a perfect prediction, right? So another values that you need to bear in mind, it's the R-squared. As closest to 1, as more perfect your model. As you can see, it's 97.97 is pretty close to 1. Same for adjusted R-squared. The R-squared is nothing but the error between one value and the other. You know what? Let me show you what I'm talking about. Okay. Here we go. Here we go. For instance, if you can see here in the prediction that it made, the red dots are the real transactions that are taking place, right? And the blue line is the prediction that we have done. So as you can see, why am I saying that it cannot be perfect? Why? Because if you can see here at the 4th year or 3 dot something, it has a difference between the prediction and the real value. This is the error that it has for the prediction. As closest to the blue line, as more perfect the prediction is, or as more linear the prediction is. So the error is nothing but the distance between the red dot and the blue line, and it's summing up and creating an average out of that to let you know how much error you have in your prediction. However, again, as I told you, there's nothing linear in this world, actually, right? So that's why we always will have error in a prediction. If you don't have error, there's a problem in your prediction. That means you are overfitting your model, right? When you have 0 error. I mean, the error must be closer to 0, but it cannot be 0. Else, you are manipulating your model. That's why it's important to understand what the error stands for. It's nothing but the distance between the blue line and the real value to let you know. But what's the important thing here is there's a trend, and the future value is closer to be predicted with certain level of uncertainty, right? However, it's not the same. What if I ask you, I don't know, let me give an example. Ayrton, if I ask you how much a person will earn after 15 years of experience, what can you answer out of this?
You say 15 years, right?
Yeah.
So we just base what I'm seeing in the model. I'll say probably like 180,000.
180,000. What if we try your theory? What if we... you weren't that bad though. It says 175,455. So as you can see here, you weren't that far. You weren't that far. Nevertheless, I mean, these algorithms will help you to get even closer to a real life prediction based on historical values, understanding the patterns behind the scenes, understanding what errors you have in your data, and it will help you to adjust your prediction and give you something more tangible, a fact that can help you to take decisions. Again, these algorithms won't take decisions on your behalf. It would give you patterns, trends, and facts that would help you to take decisions. But you were so close. Congratulations. Congratulations.
I have a question, Professor.
Yeah, go, shoot.
So I'm running the code
Uh-huh.
in parallel, as you explained, and I have different results for the residuals and the adjusted error square.
It's
So
normal.
I'm guessing this has to do with the seed.
Exactly. Exactly. You are totally right. Because as per taking different values, but it must not be that far. For instance, try running the regression for 15 years. Okay. Is this object? Let me copy and paste it. You may have it though. Yet I wanted to share it with you. Try to run this one. How much do you get? It must be closer to that one. Perhaps you can get a 100,074 or something.
I have the same value as you.
Yep, I got the same and also on the
Oh, you got the same
multiple R
value.
squared. Yep.
Yeah, as you can see on this part, it took the different samples. It's pretty close to what I have. I mean, in this time, it's exactly the same. Why? Because we don't have too many values. But as more values you have, as more error you can get, or differences, or variance, or error that you can get your prediction, but it's pretty close each time. It is not perfect. However, it gives you an idea about how is something behaving, right? Is it better? Is clearer now?
Yeah. Thank you.
Does anyone, my pleasure. Does anyone has a question? Does anyone have a question? Or you prefer me to ask random questions to someone?
If you see that the model is overfitted, how you can correct this sampling process in the program?
Beautiful question. It depends. Well, the toughest part is data cleanup. For instance, the outliers. Outlier can be a 0, or maybe you have new values. So you need to perform. Do you remember that we made a data cleanup in the previous class, that we changed zeros for the average and things like that in order to reduce or to avoid overfitting or reduce those errors? First, you work with the data. You make sure you don't have kind of extreme values, right? Because maybe you have the CEO who actually, or maybe the owner who has $2 million a month. I mean, that's not real. That's not, no one is gonna earn $2 million in the company. So you get rid of that particular outlier, right? So you get rid of outliers, you clean up your data. That's the first way that you must do in order to improve your prediction. The second is here where you have the split. In the split, first I use 1/3, right? The most value that you can have is 40%, 40% for not overfitting. More than 40% here, it would overfit your data set. For instance, it can be either in percentage, or it can be in fractions. Either one or the other works. Here I use 40%. You cannot use more than 40%, else you will overfit your model. The sample must be at most 40% of your data for not overfitting. If I use 50%, I'm forcing the model to behave in the way I want. And this is not what we want. We want the model to let us know what is going to be the prediction. It's like if you go to someone to, I'm not sure whether you believe in that, but there's people who actually read letters or read cards, right? And let you know your future based on the different combinations of the cards that they open. It's like if you were telling that person what is going to be the future, rather than allowing the cards to let you know what is your future going to be. I mean, I don't believe on that, but if you do, I mean, it's only a silly example, right? Something like that. Crystal clear?
Yes, thank you.
My pleasure. Is there any other questions so far? Okay, here I'm going to give you another hint. Here I created two plots. The first one is to show you the training test. Do you remember that the training test, we took random values out of our data, 40% of our values, and we test the model. What's important to understand here? The important thing is the blue line. the blue line. The blue line in both charts must be pretty much the same, in the same position, the same vector. Okay, so now let's go for the test set. The test set, if you remember, we take another random values as a proof of concept of our regression. So this one, this is the other model, and guess what? The line is pretty much alike, right? Let's take a look. As you can see, it's pretty much the same line, but the difference is the test set has more values within. As you can see that, what it means that the prediction is 98, close to be perfect. And how can we do it? Well, again, we can take a look to the summary to understand what's the level of prediction. As you can see, we can see it's 90% accurate, 97% accurate. It's something really good. It's something really good. So imagine that you can predict something with 97% of certainty. It's so powerful and it's so beautiful when you actually use it. Try to use it for your own purposes. I don't know, not sure. Again, this is linear. I mean, again, nothing in this world is linear, but we need to start understanding the most basic model before jumping to others. Questions?
I didn't understand what's the difference between the first plot and the second one.
You didn't get it?
No.
No worries, no worries. That's a very good point. Do you remember that first we trained our model? The training model means it took random values, 40% of random values out of this. So what it means, if we have 30, it took 12 values, random values, to understand the pattern. So it took those random values and created this chart out of the 12 random values, right? So create this chart. Afterward, it will take 40% of your values. It will take more values now, the remaining 60, to test them. And is where, just to see whether it's real or not. It's gonna take the remaining values. Let me give you an example. Here, let's say that in your test, in your training, it took this, more or less it took this one, actually it took this one, took this one, which is around number 3, it's this one, took another closer to the value, took random values, right? 30% of your values to understand the pattern. Afterward, in this, it took all the remaining values and actually applied the model to all of them to give you what's the entire behavior for your data and the prediction. Better now?
Okay. Yes.
The first one took some sample and afterward took all the remaining data to test your model, or better said, to apply it to your model.
Okay. Thank you.
Is this model clear for everybody? Roberto? Crystal clear? Nice. Dora?
Yes.
Perfect. Mr. Wild? Nice. Rafael? Beautiful. Sophia? Crystal clear? Beautiful. Brenda? Nice. Ibera? Beautiful. Federico?
All good.
All good? Wonderful. Emmanuel? What do you think?
Yes, sir. Everything is well.
Beautiful. Beautiful. Stephanie?
Yep. Okay.
Wonderful. Brenda? Brenda? Okay.
I have another question. When
Yes, please
you
shoot.
set up the training set and the test set, I see that the only difference is in the function split, that you compare equal to true or false.
Exactly. Exactly. Here. For instance, here, when we perform the regression here, exactly. Here, we are saying, okay, for the training, what I'm letting it know, this split true, the split means take random values. Take random values using this ratio.
Yes.
Here, what I'm saying false, because I'm telling, take all the values, not only this 40%, take all the values. That's why I say, don't split it. Take all the values and use them to plot them, as you can see here.
Okay. Okay. Thank you.
My pleasure. My pleasure. Mario, crystal clear?
Everything okay, sir.
Beautiful. Ayrton.
Crystal clear.
Wonderful. Naim. Or Naim.
Yeah, Professor. Everything
Beautiful.
great.
Wonderful. Wonderful. Uriel. Uriel, better say. What do you think?
Clear, Professor. Thank you.
Crystal clear? Fabian? Wonderful. Thank you.
All clear. Thank you.
My pleasure. Okay. Why is it important to work with this model and understand it kind of step by step? To be honest with you, it took me some time, for not saying years, to master it. Why? Because understanding what happens behind the scenes takes a while, right? So I know the math behind the scenes. I needed to do it by hand in order to understand what I'm saying. So that's a painful part. And actually I have so many books about the algorithms behind machine learning, but I don't want to overfeed you with that information, but there's a lot of information behind the scenes. That's why I'm trying to simplify it for you to make it clear, because as you can see, all this math is nothing but the results of so many equations and so many processes that takes place behind the scenes. So in other words, these powerful tools, it's a wonderful engine behind the scenes that will help you to perform predictions very close to reality with a simple, so kind of 50 lines of code. So with 50 lines of code, actually you can replicate this same model that I shared with you. Just make sure to understand which one is your dependent and which one is your independent variable, right? Like for instance, your forecast that you perform on a yearly basis in your companies depends on the previous sales for the previous years, right? That would be your historical records that can help you to predict what is going to happen this year. And it depends on perhaps products, or you can do it by line of business, or maybe by cost center. So the cost or the results depends on the effectiveness of each and one of the dimensions that I already told you about. Try to apply this to your companies, and it'll help you to understand how to behave or what to do. Okay, so what if we take, to refresh your minds, because we will take a look to another model, which is really nice, and I'll let you know why. So let's take for 8 minutes break. Let's take 8 minutes break. Let's return back by 7:40 and continue with the other algorithm. So you need to refresh your mind. See you in a moment. I think it's the time that we established, correct, Guillermo? We said 7:42, correct?
Actually, it's 7:40, but
yeah. Oh, okay. Oh my God. Then it was my bad. So I don't know why I had that in mind. But anyway, so let's resume the recording just to make sure that everything is being recorded correctly.
Recording in progress.
Okay. So now that you are fresh your mind, and so we will apply the same model, but now comparing different values or comparing different categories, better said. What will be one example? Let's say that you have a portfolio of investments and you want to find out which ones or which combinations would give you the highest earnings or the highest value for your company, right? So in other words, we will take a look to multinomial regression. The multinomial regression, it's a linear regression, but apply to more than one category. In the previous category, we have wages and we have years, right? Where actually the wages is the fact or the number, and the years of experience was actually the category, right? Which is nothing but the category describes our data. Okay. So in this case, we will take I look to another example, which is going to be startups. So the startups file, let's see what it has. Pretty much it'll have a list of companies, and it would give you a mix of different investments that the company does, and also the profit out of that. So in other words, let's say that company one has invested $165,000 in R&D. They have spent $136 in administration, $471,000 in marketing. That company is located in New York, and the profit out of that is $192,000, right? So same for different companies. Top of mind, can you find out which one, which mix of investments? Let me rephrase that. At simple side, can you let me know which one would give you better earnings if you invest in R&D, administration or marketing? Do you know top of mind or quick side? Can you see which one is going to give you a best return of investment? What do you think?
I think no. I think that it depends on the industry and other stuff. It's difficult to say just looking at this information.
You're right. You are totally right. So imagine the situation that I invite you to my company and I ask you, okay, you have one shot. If you have $1 million, you invest in my company and I would give you in return X amount. But it depends on your decision where to invest on in every single one of the areas. I mean, it sounds good, right? Because you're going to get the return of investment. But up to this point, you don't know how to maximize the investment in order or maximize the division of your investment or your portfolio in order to get the maximum return of investment. That's exactly the approach that we will use here, right? So as you can see, it's very powerful, very, very powerful, because I anticipate that some of you need to take decisions on daily basis or maybe monthly or yearly basis, where to put the money of your company in order to maximize the return of investment for your company and maximize and simply create more revenue and more profit, right? So in other words, if you use this algorithm, it would help you to prioritize where to invest the biggest amount of money in your company and so on and so forth, right? So let's do that. Let's do that. So in this case, we will use the multinomial regression. So the multinomial regression, as the nature of the word says, multi, right? That means that it will perform several regressions in a single shot, right? So in this case, I know top of mind that the dependent variables are, do you remember that we talked about the levels? Do you remember when we declared level what it meant? Do you remember when we applied the level method, what we were looking for within a vector? Levels, do you remember? The quick explanation would be the different values that we have for a dimension, right? Like for instance, if we have states, let's say that we have New York, California, Florida, and Texas. So, but we will have as many of those words depending upon number of transactions, right? So we can have 1 million of transactions for Texas, we can have 1 million transactions for New York, and so on and so forth. However, we don't have 1 million categories, we only have 4. So when we do levels, out of the entire, it gives you the unique categories for your entire data set. Do you remember that? We saw it in the second class. Well, try to take a look to that one because that one is important. So if you remember, well, here we will use something called factor. So the factors is where actually we took the different levels and understand all the transactions for each one of the factors. That's what we are doing here. So for the performing the multilinear regression or multinomial regression, we need to create factors. And the factors means for each and one of the different categories that we have, we will need to perform a regression to understand which one has the best behavior. So in order to do that, first, we will create the object that will lead the algorithm to understand how many regressions needs to do. This is dynamic in the sense that based on the data that I have, I can specify what I would like to apply the multinomial regression and when. Example, here, we use the value factor. If you remember, when we talked about factors, is nothing but let's imagine that here we have, I don't know, repeated numbers, right? Let's say here, 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 and here we have 4 and 4 here again, and 4 and 4 and 4, and we have 5 here, 5 here, 5 here, right? So creating factors means it's gonna take all the different values and let me know which ones are different, and also let me know how many transactions are per each one of them. Let me give you an example. Let's say factor, here we go. So let's give a filter here. And here I'm gonna say, okay, the algorithm, what is gonna do? Okay, first it takes the 1. All the unique values. As you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 different values. That means we have 11 factors. In other words, it would take the unique values and create 1 factor per each and one of them, right? Crystal clear so far? In other words, what's important about the factor? Well, as more values the factor has, as more weight it has for the entire world of data that we have. So that's what we are doing. So in other words, here, we are creating the factors based on the state, and we are taking 3 levels only, because I only care about New York, California, and Florida. Again, if you have more states and you want to include more states, you can do that. But let's create the factors. So the factors, what it will do, it will identify how many times New York appears, how many times California appears, how many times Florida appears, and it will give a weight to each and one of them and assign a level. The highest level will be the one who actually has more weight into the entire data. Second level, or the number 2, would be assigned to the second most important state in the entire data. And third place will be, of course, the last but not least state that actually gives you the less amount of data. That has the less weight in the entire world of population in your data. Crystal clear so far?
Yes.
Beautiful, beautiful. So now we will use a library CA tools. Do you remember that CA tools is the library that contains the linear regression method, right? Linear regression algorithm, better said. Afterward, do you remember what the SID is for?
Yes, like for taking a random sampling.
There you go. There you go. To let it know that for a random sampling, it will take it will use integers and just edit random. It will take impositional different values out of the entire data set. Exactly. You got it. Do you remember any other volunteer? Let me take another volunteer. Any other volunteer? Emmanuel. Emmanuel, do you remember what was the split for?
What was that?
The split. The split. This one.
Yeah, it's to divide like the test data set with the other part. So then to try to see how good is your model in this case for the R square to see if it's showing a linear correlation or not.
Well, you included more things that are in the upcoming steps.
Okay.
But I think let's ask Roberto. You wanted to answer?
Yeah, actually, complementing
the comments of Emmanuel.
Thank you.
I would say is like dividing, just dividing or taking few samples of the data.
Beautiful. How many?
I
How many
mean,
sample? Or how can you
40%?
determine? There you go. Beautiful. Exactly.
okay.
Less than 40%.
Exactly. Well, we are saying 40%. I mean, the rule, yes. The what you mentioned, the rule is less than 40%. Of course, the maximum value less or equal to 40% is the maximum value that you can put here. But yes, we are telling the algorithm to take 40% of our data in order to understand the patterns behind the scenes, right? So now let's perform the split. I won't show the values. Actually, we can see them here, the split. Here we can see that it took the first value, it took some other values, right? So we can take a look to the split, but now you know that it took random values of our entire world to understand it. Okay, any other volunteer to let me know what's the training test, the training set doing here? Any other volunteer? Or I pick the name. Right? It's much funnier. I'm just kidding. So Uriel, I'm sorry, who was volunteer?
No, I have a question.
Oh, thank you, Brenda, for volunteering yourself. Go for it.
When I run the split,
Mhm.
it says that it has an error because it could not find the function samples split. So I don't know if
It's
I have,
you need to invoke the CA tools. Did you invoke the CA tools? The
yes,
library? And you
just let me see if I run this again. Okay, I have it.
Yeah.
Okay.
Yeah. You need to
Sorry.
run the CA tools because here this library contains all these methods that need to be applied along the way.
Okay.
But now taking advantage of you're volunteering. Thank you so much for that. You are awesome. Can you please explain us what the training set is doing here? Actually, let me highlight both because those are related. Samuel, okay, you know what? I think you have help here. Samuel, you want to help?
Yes, sorry.
Go for it.
Yeah, I think that the training set, what we are doing there, putting the true is executing the 40% that we put in the other line. And on the test set, we are, well, the false, we are going to take all the information that we have.
And apply the model to all the information, right?
Right.
Beautiful. You got it. You got it, Samuel. Thank you so much, both. You got it. That's the important thing of understanding the explanation of this algorithm, that you're understanding step by step what's going on in order to be capable to apply it as many times as you need, right? So up to this point, there's nothing different. Well, the vector is different, right? Because the previous data set, we didn't have to create a vector. But up to this point, from here to here, it's pretty much alike, right? Everything. Okay, guess what? In the next factor or in the next method, there's a slightly difference here. As you can see, we declare the regressor object. Afterward, we say, okay, we will use linear mode. And this time around, we say formula, and we are having profit. We have the virgula, and we have a dot here. What do you think it means? Do you remember that before we specified something, right? What we said? We said dependent, and afterward we said independent variable. Do you remember that it happened in the other model, in the linear? Why do you think that here we are putting a dot? Why do you think?
Maybe to take all the data.
Beautiful. Exactly, Sophia. Wonderful answer. Exactly. Because we are taking all the vectors that we have in our algorithm, because by fact, we want to understand the relationship among them. So what is going to happen? That means, let me get rid of this. That means this time around, we will have something like this. Right? So we will have something like this. We will have something like this, right? Maybe a different color. We will have something like this, or maybe have something like this, and so on and so forth, right? Depending upon whether this one is R&D, right? R and D, right? Or maybe marketing, or maybe, what was the other one? Do you remember? Marketing, R&D, administration, and so on and so forth, right? So in other words, depending upon the combination of this, each and one of them have a different trend. Each and one of them, in the trend, what it means, that it has more or less impact in our profit, right? So as more harsh the trend is, as more impact it has, as more vertical, as more impact it has, right? So based on this image, which one has more impact? Based on the image, I mean, it's only random. Which one do you think it's gonna have more impact in our revenue, or in our profit?
R&D.
Beautiful. And there's another one that it goes side by side, right? Which is the other?
Marketing.
Marketing.
Beautiful. Beautiful. Exactly. That's exactly what is trying this model to explain you. Which one has more impact? More impact in revenue based on this behavior. Now it's clearer now? What a beauty, isn't it? Because it's based on mathematical methods. There's no manipulation behind the scenes, unless you manipulate the data, of course. But behind the scenes, there's no manipulation in the code. There's no manipulation in the decisions. The algorithm itself, it's gonna give you the power to understand what's going on. So let's go through that. So as you mentioned, let's create our object, which is called Regressor, which is gonna perform a linear modeling to understand what's the relationship between the profit and all the categories that we have included as part of that. First, let me remove them all these, let me remove them. So for not polluting the answers, right? And actually, let me remove all the variables as well. I cannot remove them because we will need them. Anyways, so now what is gonna happen? We create the regressor, we create regressor object, let's run it again, to let the algorithm know, take the profit and compare the profit with all and each of the categories that we have. Okay, beautiful, beautiful. Now we need to perform a prediction. First, we need to do it for, actually we do it for the training. Here we're taking the training, as you can see that. In everywhere what we're gonna use. Now that we have trained our model, now our model knows how to behave. Now it has created these lines to understand what's the behavior for each and one of them, right? But only taking a few samples, right? Maybe a sample here, another sample here, a sample here, a sample here, sample here, sample here, sample here, and sample here. Just to give you an example, right? A sample to give you an example. That was a good one. Anyways, the magic words. Anyways, so now, as you can see, crystal clear so far. Now we are here, we have done that, taking random values out of those regressions and understand how those behaving. Now, what we are doing here, any volunteer that can give me the answer right here, what we are doing here? First, take a look what variable we are using, or what values we are taking. So what we are doing here.
Proving if the algorithm is correct.
Yes, actually, yes. The way you phrase it makes sense, because what we are doing, we are taking the entire remaining data and we are applying the model to the entire remaining data to actually take all the values that creates each and one of the vectors. We are taking all the random, I'm sorry, not random, all the values that are part of a vector to actually prove that we are performing a real prediction. Okay, beautiful, very good answer. Thank you so much. So let's do that. Now, as you can see, it is called Y. Y we said is our dependent variable. Do you remember that? Y is our dependent. X is the independent. And Y in here, but that's why it's called Y prediction. This is the dependent prediction, the dependent variable. So now let's take a look to that one. What happens now? It's gonna take for all the possible combinations, it's taking all the combinations possible and trying each and one of them. Is taking R&D, what's the behavior? Is taking marketing, what's the behavior? Administration, what's the behavior? And testing the results depending upon the weight that each and one of them has. Let me give you an example. Let's imagine that we have administration, R&D, and marketing. And let's say that admin has 0.1, R&D has 3, and marketing has 0.5. Is the factor that is going to help us to understand how is everything behaving, right? And let's say that we invest $1,000, right? So the total or the total return of investment would be the combination between the $1,000 multiplied by 0.1 plus, actually, let me put the parentheses here, plus the percentage given by this same $1,000, right? Parentheses, plus the weight that R&D has multiplied by the weight R&D has. I mean, it's a silly example. It's more complex than this, but just to give you an idea how it works. In afterward, the last but not least, it will be the $1,000 plus the combination of marketing, right? Oh, something went off because I missed here the multiplication. Beautiful. Thank you, Fer, for that. Thank you. That was amazing. Congratulations. I'm sorry, being a little bit sarcastic here, right? So this is an example, right? This is an example. Like if we invest $1,000 based on, if we invest 1%, I'm sorry, 10% in admin, I don't know, 30% in R&D and to 5%, 25%, I'm sorry, marketing, we will get a return of investment of $5,600, right? It's kind of what we are doing here, trying to identify what's the combination for each and one of them in order to understand how to maximize our return of investment. That's what we are doing here. So based on that, what if we take a look to the results? What if we take a look? Okay, something else that I need to explain here is that let's run the prediction, right? Let's run the prediction. Let's create the object, which is YPred, which is gonna take all the values that the regressor object has, which is nothing but the profit and the combination of all the categories, right? And it's gonna take the test set, which I told you or you mentioned that it's gonna take the entire world of data and try one by one to understand all the patterns, right? So up to this point, now we have the results. But what if we take a look to those results? So let's take a look to those. Actually, this is going to be spoiler alert. Here we go. For instance, marketing is giving us this trend. Administration is giving us this trend. And R&D is giving us this trend. So simple side, which ones are more impactful in our profit? I repeat, R&D, administration, or marketing spend. Which one?
R&D.
Beautiful. There you go. As you can see, R&D has a lot of correlation with the entire model. And as more we invest in R&D, as we can see in the trend, right, is the return, it's gonna give us the highest level of return of investment. However, we cannot invest 100% of the money in R&D. We need to invest also in marketing, and we need to invest in administration, right? So in other words, we need to balance which one is gonna give us the which can maximize the return of investment per each and one of the areas. So now it's exactly what we're gonna do here. What we are gonna do here. Let's say that you have, I don't know, $1 million, right, to invest. So now that you have your model, now you can, based on what if scenarios, you can play with your investment and see how much you can get in return. For instance, if I can see here that based on what I know, R&D is the one that I need to invest the most, isn't it? So that's exactly what I'm doing here. I'm investing $165,000. In administration, for some reason, I'm investing 136. Why? Because I need the people who actually is gonna work with the other people, hire, making sure their performance. I mean, it's the administration that we need to invest in order to keep the operation going. We need to invest on that, right? But let's try to maximize it and invest as less as we can. And marketing and spend. Let's spend $47,000. I'm sorry, $471,000 into that. And what is going to be the result for, in this case, do you remember what state one was? State one was New York, right? So we will test for New York what would be the prediction based on that portfolio that we have created. Guess what? If we invest that amount in New York, the likelihood of 90% to earn a $193,000, it's simply tangible. It's very possible if we perform this portfolio investment. So what is going to happen if we invest other, let's give another random values, $175,000 for R&D, $200,000 in administration, and $271,000 in marketing for the second state, which is California. Let's see which one will give us. Actually, you know what? Let's invest exactly the same amounts to see which one is more profitable, right? Would be an interesting analysis. I think that it's a fair analysis, so let's do that to see which state would give us the highest return of investment, investing the exact same amount. Those are the tests that you need to perform in order to understand how to invest your money. I mean, it's as you can see, for instance, again, we said New York is the return of investment is $193,000. For the second one, I believe, is California. California, there you go. California with the same amounts, is gonna give us $193,000 as well, with a few difference. However, California is giving us a little bit more. So if we invest the same amount in both states, we can expect the similar return. But let's take a look to Florida. Now, guess what? Florida is not that far away. Nevertheless, is not the best state to invest on. We are getting $187,000. So based on this, we can see that if we invest the maximum amount in New York and in California, we will maximize our earnings based on, we need to invest more in R&D. In second place, invest in marketing. And last but not least, invest in administration. Can you see the decisions that I took just by taking a look to this algorithm? And the likelihood to be successful is more than 90%. So, as you can see, without knowing the data, without being an expert on what I can see here, I took decisions based on the algorithm that I used in order to create portfolio and understand what's the possible behavior for my investment in the future, right? I mean, what do you think about it? I mean, do you like it? Do you dislike it? What do you think? Do you find it powerful? Do you think you can use it? Please let me know.
I think that, yes, I consider it very powerful and also much faster. Like we don't even we didn't even look at the actual data like line by line.
It's
So
very
that saves you a ton of time.
I have just a question.
I think someone is breaking up. Thank you so much, Anna. I really appreciate it. Yes, because that's a powerful thing about this, right? That you don't have to open the data set itself, right? And oh my God, let's see what's the data. I don't know. Let me take a look. Oh my God. So imagine analyzing this by slicing and dicing filters, maybe creating pivots, right? And how would you test the what if? In Excel, you cannot do the what if. It's very difficult to perform the what if scenario. And the what if scenario means, what if I increase the investment in this area? What if I increase the investment in this other area? What if I balance or I invest the same in all of them? You cannot do that, or at least it's very difficult to do it in Excel or any other tool. That's why this tool not only shows you facts about your data, but also gives you the possibility to try and stress different scenarios based on your criteria. Again, these tools won't give you the answer, only help you to, out of the entire universe of data, focus on specific scenarios that you can work on. But for sure, you need to understand your constraints, right? Because you don't have unlimited amount of data or unlimited amount of dollars, right? If they tell you, if your company tells you, you only have $100,000, you only have $100,000, and you need to play with that. You cannot invest $100,000 in every single area. You need to decide which one to balance. Nevertheless, by using the what if scenario, you can try all of them, right? For instance, first, the same amount to all of them to see which one has more power in the results. And afterwards, say, okay, now that I have analyzed which are my top 10 or my top 20 or my top whatever, I'm gonna put the maximum amount to those, and to the remaining ones, use the minimum amount that I need to invest on those. Because why? Those don't have that much correlation to the results. In other words, put the good money into the good money. That's it. Never put good money into bad money. That's a bad rule. Go for it, Roberto.
Yeah, and I will also add that with these tools, you create like a skeleton or a template for you to keep running numbers. If the information or the database updates continuously, you just throw the database and then you will get all the analysis in a matter of seconds.
Exactly. That's the great power of this. You don't have to redo all over again. Because when you get an Excel or when you get an analysis, you need to invest hours on doing so. This one, you need to do it once. Maybe, if they include another state, that's the only thing that you need to change, the vector, that's it. Or maybe if you include other part of the portfolio, right? Like investment, let's say operation, that you increase that variable that you need to invest in operation, you include it here, and guess what? The algorithm will keep on working over and over again. So that's the beauty of this, that you can replicate it over and over again with the same level of precision. You don't have to redo that much. 3, it can work with millions and millions of records with a minimum error. And 4, it will give you powerful insights without requiring to do that much effort for your own. I mean, now it starts making more sense, right? About what we have seen previous classes that I told you about vectors, told you about dimensions, dependency, and so on. Also the charts, right? The charts were really nice. So, but now it gives you an understanding how to relate both, how to understand data, how to understand the transactions behind the scenes using the methods, and how to visualize it in order to understand and help you to visualize what the current standing point of your business that can help you to take future decisions. Okay, I'll show you another algorithm which is not part of the class, which is not part of this class in particular, but just to give you an understanding about the comparison between linear and nonlinear, right? So this is something I'm going to show you the next class, but yet I wanted to show you comparing the salaries. What's the difference between using linear regression and non-linear regression, right? Okay, let's do that. Let's use the same, so actually this one, let's use the same one that we had before, which is, you know what, let's keep that. It's the same, just to give you the example. So this one will give you a non-linear regression, just to give you to understand, because I told you, in this world, nothing is linear. However, first you start with a linear to understand the pattern, to understand trends, to understand certain factors that may lead you to think about where we proceeding with. However, if you want to increase the precision, you go from a linear regression to understand patterns, and afterward you jump into a non-linear to try to identify, for instance, seasonality. Seasonality is something that cannot be identified in a linear regression. Do you know what seasonality means? Anyone who can give me an example of seasonality or an explanation about seasonality? Or do you want me to pick the volunteer?
Yeah, I can do it.
Beautiful.
For
Go for it.
example, in the business that I am, I sell pest control products. So at the winter, the sales are so low. So in the spring,
and summer or spring.
yeah, in the spring the sales increase a lot because it's hot, the weather. So that is the seasonality.
Yeah, and for you it's quite tangible. For you, every year is the same. But there are some other business that is not that tangible. That actually there's something else that we need to bear in mind. That every single product and every single product, every single service has a different life cycle. What it means? The life cycle. Let me explain it. Don't save it. Usually, for instance, let's talk about cell phones. For instance, we have cell phones, right? Cell phones here. Let me ask you a full question. Do you sell the same do you think that iPhone sells the same just when they deliver the new iPhone rather than 6 months later or a year later? Or 2 years later?
No.
No, right? That's a beautiful answer. So what happens is that each product has its life cycle. All products have its life cycle. What it means? That when you simply throw it to the market, right? You showcase it, you show it, let the world know that the latest and greatest product is coming along, the people start buying it. So the trend simply is positive, right? Afterward, it touches its maximum value. And later, it starts dropping down. However, what they do, let's say that this is 1 year and this is 2 years, right? What happens is in the second year they start offering you the new product. So it follows this trend. Actually, I'll change the color. Right? So when the other product is dropping down, they make sure that the new product comes across. This is the break-even point, right? What it means that by this point is where you are risking a little bit, but you keep on earning in the same fashion. When the new product is launched and so on and so forth. That's a way that they keep their profit stable over periods because they are bringing a new iPhone over or a new product over, taking into account the life cycle of the product itself to maximize the revenue and the profit and to make sure that they keep on earning even the same or more over the periods, because this is only sales in units, but in dollars, that is something different because the iPhone or the new product does not have the same cost as 2 years back. It's more expensive. So what it means, it's that their earnings is like this. Oh, not linear, right? I told you nothing is linear, but just to give you an interpretation about how the business work and how you can apply these methodologies to understand those seasonalities, those capabilities, and try to understand when is the break-even point to launch the new product or where to change the machine to understand that you don't have to lose the assets, you don't have to invest more money into repairing and so on and so forth. So machine learning can apply to whatever you can think of that you can predict. Quality, revenue, return of investment, I don't know, attrition, maybe wages, salaries, taxes, whatever. Everything can be predicted if you have, of course, historical records. Is there any questions so far before we keep on going with the algorithm? It's powerful, isn't it? Very, very powerful. So for this non-linear regression, this is called polynomial regression. What a polynomial regression means. Do you remember that we mentioned multinomial, right? Multinomial, we talked about different products that we are going to perform in regression, or multiple areas that we are performing regression. Crystal clear? We use different categories. Crystal clear? However, a polynomial regression is letting us know that nothing is linear. So if we say this, right, we are saying that this is a linear performance, right, which is y plus x multiplied by any factor, right, multiplied by, I don't know, 0.5, for giving an example, right? This is a linear behavior. However, when we say that something is not linear, we have more factors that are involved in that, right? This is something non-linear. What it means, we have an inflection, we have a drop down here that can be the famous seasonality. Why do we have a seasonality here, right? This could be a seasonality itself, right? And this where actually we say this is non-linear. It has two inflections. That means it's an equation of level 3. In other words, this one would be perhaps instead of giving y plus x dot multiplied by 5, it would be, let me do it. I'm not sure where I can do it here, but it would be y plus x, but this will be times, let's say times 3. Where is the times? Oh my, here we go. Oh no, this is not the one. Where is the thing? Oh my, I should change the language to my freaking keyboard. Oh, where is that? Well, let's say, okay. Exponential. I don't know, let's still make it clear. 3. Just like that. So if we have 3 inflections, means that that equation is level 3. As more changes of direction we have, is the level of the transaction or all the prediction. Crystal clear? Crystal clear? So for instance, what level would this be 1B? What level it is?
2. Oh, 3.
Sorry, no, you're right. Sorry about that. There you go. Which one is level is this one?
2.
There you go. Beautiful. Because it has 2 inflections, right? It went up and suddenly went down. This is level 2. This one is level 3. And what would happen? Well, if we have something like this, I don't know how to make a level 4 here, but let me see what I can do. No, I cannot do it. But imagine that we have a level 4, that means it has 4 inflections, right? So now that it has explained this, we need to visualize that into our salaries projection. So let's do that. So this time around, let's take our data set. Actually, I'm sorry, I have not defined the data set. There you go. Define the data set. And let's take a look to the data. First, actually, data set, this is going to be data set 1, just to show you the difference. Just to show, actually, you already know how to slice and dice the data, so I don't have to explain that. So let me run this one first to show you what is this about. So view data set. View data set. Here we go. So this one, as you can see, we have based on the position and based on the level, we have a salary, wages, just like that, right? However, this time around, we have 2 factors, right? Which would be position, and the other one would be level. And last but not least, which one is the dependent variable? Which one is the dependent variable?
Salary.
Salary. And which are the independent variables?
Position and level.
Yeah.
Position and level, both, right? Because you can have an analyst level 1, 2, or 3, or 4, or whatever levels you have in your company. So what you can have the dictionary of what are the ranges or salary or wages that you can have. In that way, you can perform the truth or bluff for anyone. So let's do that. So with the polynomial regression, what we are doing the same thing. We are invoking the library, the same library, CA tools. We are performing the seed, which actually we're establishing that there's a threshold, right? That is going to take a sample of numbers out of the entire data set. We are saying we are taking 2/3 of the data set to train or model. Afterward, we are saying, okay, train it. And afterward, take all the data and apply the model over and over again. Let's do that. You're familiarized with this process. It's the same process. Let's clear up all this for not polluting the results. Go for it, Roberto.
I have a question, Professor. 2/3 is around 60%, right?
Oh, that's a very good point. So that means it's an error, correct?
Yeah.
There you go. You know what? You're totally right. Let's take 30%. Which would be 1/3 as well, right? 1/3. Beautiful. A very good catch. Very good catch. So let's do with 1/3 or yeah, 1/3. And afterward, let's train our data set and let's apply it the same sample, or I'm sorry, the same algorithm to the entire data set. Now, we will do the same. Here in this time, we need to perform the feature scaling. Why? Because as per having different inflections, we need to be extra careful about what pixel to use to project the transaction. That's why this time around, we use the scale. The scale is nothing but, as I told you before, it would say, oh, you know what? This transaction maybe in the image would be that 003 pixel. Maybe this one would be that 007 pixel, and so on and so forth. So it needs to identify based on the Cartesian chart where is going to be the relationship between X and Y to specify what's a pixel, just like that. That's why we are doing the feature scaling. So we will do the feature scaling for the entire error. Let me do that again. Actually, this one must work. Must be numeric. Okay, so that means that the data set is not cleaned up. Okay, let's take a look to the other. Actually, this one was important. I think I should have tested this one before. Why? Because it means that we have new values in our data set. Let's see whether it's true. No, actually it's not. It's not new values, but I may need to work to fix this one. That's a problem of improvising in class. Okay, let's continue. Let's see if we don't perform the feature scaling, let's try this. Okay, X must be numeric. You know what? Oh, this is taking 2 and 3. Let's take a look to the data set. Oh, you know what? I made a mistake here. I didn't invoke that one. So here, okay, my bad. Because I was taking a value that is not numeric, which is here. Let me take a look here. Data set. I mean, no, this is not the one. Here we go. This is, no, where's that? Ah, did not take it. Anyways, let me invoke it again. Polynomial regression. Here, for instance, the data set. This data set, it's gonna take, here we go. Let's invoke it again. And let's take the data set one more time. So what we're doing here is that we are limiting to only the values, not the categories, is to include only the values for each and one of them. That's why we create this new data set. We can only train facts. The dimensions are only used to correlate those facts to each and one of the transactions, right? So that's why we need to perform that data set. So here we are taking only 2 and 3. So let's take a look. Actually, let me show you here. For instance, the data set here is taking all the values, right? Only 2 columns. Here's the feature scaling. Can you see that? Rather than giving you 1 and 2, 3 and 4 and so on and so forth, is giving you the scale. Is giving you the scale as it would look in the chart. That's why we perform this scaling training and test set. Go for it, Anna.
Thank you. But when you do the scaling here, like you're letting like the code will know what scale to use because
exactly
right. Okay, because last time we had to write that it was continuous, right? Like in the
exactly. There you go. Here you are letting the code know to identify the thresholds.
Okay.
And based on those pixels, identify where is that going to be positioned based on the area that you have available. Is what we do here with the scaling. My pleasure. So now let's apply the regression to that algorithm. As you can see, it appeared a new prediction, but this time around is taking all those feature scaling, comparing one by one, and now it's giving us a prediction for each one of the values. But if you remember, I told you we need to specify the levels, right? In this case, I mean, we can specify one level here, for instance, and we can invoke the dataset. Let's take a look. Let's take a look to the chart to see how it looks like. There you go. As you can see, it's linear, right? If we run only one. But what is going to happen if we invoke the number 2? There you go. Now let's invoke it. As you can see, here included a little curve at the bottom. Why? Because it's identifying that it is not linear. This is the linear regression, and this is the new projection. As you can see, it's totally different. Here, it was predicted that this person would earn, based on the level number 10, that person should be earning around $65,000. But guess what? No, that person should be earning around $100,000. Can you see that is not linear? That's why we use this kind of regressions, because these ones are gonna help us to identify whether the patterns are linear or not. But as you can see here, the salary is not linear. It's something that depends on the age, the experience, the responsibility, the role, and so on and so forth. That's why as more years of experience you have, as more you must earn. So all these charts will help you to visualize how the salary must change depending upon of how much you are progressing in your career. For instance, let's say that, I don't know, you want to perform a regression for someone, what experience, what level of experience, how many years?
10.
5? 10. Ladies first, I'm sorry. I'm old school. So 10 years of experience, if it were linear, right? Let's take a look. It says that that person must be earning $613,000. However, let's take a look how it would look like if it were nonlinear. Based on 10 years of experience, we will use the different levels that we established. And let's see, guess what? No, that person must be earning $988,000. Can you see? It's a huge difference, a difference of 30%. That means that if you want to hire someone at this level and you don't offer the first wages to him, guess what? When are you going to fulfill the position? Never. That's why you need to bear in mind that nothing is linear, right? Here, to someone with 10 years of experience at that level that can be a VP or whatever, right? We were offering $13,000 a year, while that person must be earning almost $1 million a year. So that's why it's important to bear in mind that nothing is linear, right? So you can apply the same model. As you can see, the only thing that I needed to do is to train my model until here. I train my model only using these lines of code, only using these small lines of code. The remaining ones is nothing but how to show the data. And I use the predict option to see, okay, based on that, those patterns that it has identified, now I need to specify the levels, years of experience, and I can predict how much that person must earn depending upon their experience. What do you think about this model? You like it more? Makes more sense? It's piece of nothing? What do you think?
Well, I think it's more realistic, no? Like it's more like what really happens.
Exactly. That's the main point. That as more realistic you are and as closer the prediction is to reality, as more successful you would be taking decisions. That's why it's important to use different models. Don't stick to one. That's what I want to show you. I mean, despite it wasn't part of the class, that's why I wanted to show you the polynomial regression. It's something that I was about to cover in another class, but as per having enough time and as per being a topic that can be a good comparison, that's why I took advantage to show it now, right? And actually, I think I'm gonna change the program to do that because it's important to show that linear and nonlinear has different behavior. So, questions so far?
Yeah, Professor, I have a question.
Please
In
shoot.
the class of finance, I remember that we did a exercise about regressions in Excel, but I remember that professor told us that we can't use seasonality. And I see that in this case, there is an advantage because we could use it. I mean, is it right?
You are totally right. You are totally right. Of course, to identify seasonality, you need to use dates, right? Rather than levels. It is something that you can actually do, right? Apply it to identify seasonality. You can use 2 years of data because you cannot identify seasonality with 1 year, honestly. Why? Because maybe 1 year is during pandemics. Just to give you an example. Pandemics was totally crazy about seasonality. It broke all the rules that were in the global market. It broke all the rules. Simply broke all the rules. For instance, we never anticipated that diapers or toilet paper would have been the top seller for that particular season. I mean, why when pandemic started, people started buying toilet paper? That doesn't make any sense, right? I mean, I would have bought beer, right? Because we noticed that after a couple of months, beer was sold out, right? And we were like, oh my, we were wrong there. We were wrong there. If we had this model, we would have anticipated that actually beer is the thing that should have bought before. I'm just kidding. It's not even funny. But just to give you an example about how sometimes that's why I suggest you to use more than 1 year to identify seasonality. Because with 1 year, you cannot stick to that. But if you include 2 years of data, it would give you the based on trends of this. Let's imagine that these are 3 years in a row, right? For instance, you can see here, like maybe this is the first year, you can see that there's a drop down at the middle of the year, right? Maybe this is another year, slightly drop down, yet still increasing, and so on and so forth, right? It will help you to identify, I mean, this is a silly example because it's not like that, but those inflections, and as more levels you include, because you can include more levels here. Let me see whether we can include more levels, because I think I did not specify it as part of the algorithm, but let's take a look. Yeah, I mean, it won't take the more levels. Why? Because in the here in the algorithm, we specified only, you can include another level here, for instance, here. I mean, let's change it to level 5. Here we go. Change your entire model to include that particular behavior. And afterward, now you can run it with a new value that you have included there. Oh, I missed the comma. This is interesting. Oh, my bad. So now, most probably, it must work. Level 5 not found. Yeah, we need to run. We need to include it there everywhere. But in case you wanted to include a new level, you need to include it here. You need to include it. You need to include it here, inflection level, blah, blah, blah. Now, this is only for the chart. Actually, this one should have worked, but you need to retrain. It was retrained. And I mean, this one should have worked. Why not? Okay, there you go. It worked, and so on and so forth, right? So you can apply it. You can include as many levels. The level not found. So we need to redeclare this one.
We need to change
yeah,
the letter. It's 14
yeah.
versus 15.
Yeah, sorry about that. You are totally right. There you go. There you go. Yeah, I was making a mistake of repeating level 4 and level 4 one more time. So, but as you can see, you can include as many inflections as you may think of in order to identify as many years, as more inflections that you can have in your prediction to understand whether there's a seasonality or not and how to adapt to that. Does it answer your question?
Yes, thank you.
My pleasure. Okay. What if these remaining 16 minutes that we have left? So today, as you can see, today we finished a little bit earlier with the class. So what if I tell you what is expected for the next assignment? What do you think about it? Okay. For the next assignment, I'm sorry, does anyone have any question? Because first you have 2 assignments, if you remember. But guess what? For the first assignment that I gave you previous class, I already gave you the hints in a separate file. Why? Because I want you to focus on this one. This one is much more powerful and makes more impact into your learning experience, right? So because this is the class number 3, and I gave you an announcement where actually I give you the code that you can use, and you just need to modify in order to use it. That's it. This one, the help to solve, this one contains all the lines of code that are required in order to perform your analysis. Why? Because I don't want you to suffer with the previous analysis. Here, it includes everything. It includes the scatter plots, include all the charts that you need. The only thing that you need to do is to analyze it and give your takeaways. That's it. You don't have to recode anything. It must work in the fashion that I showed you to you. Why? You may think, okay, you are giving us the answers. Why? Because I want you to learn, not to suffer, right? So what I need you to focus on is on the next assignment. The next assignment is actually a real challenge, a real challenge. For instance, where is the assignments? Let's go to assignments number, there you go, number 4, here we go. The number four, I gave you both. I gave you both the linear regression and the salary, right? Here's the salary. So based on linear regression, you need to get all the statistics that I told you about, right? To get the R-squared, to get the RMSE. It's something that you...
Buenas noches. Buenas noches. Oye, estoy...
Beg your pardon? I think that question wasn't for me. Yeah, I think it wasn't for me. Oh my God, I was so scared because it looked kind of freaked out. Anyways, so using the statistics methods that I showed you about, you need to get the RMS, the errors, right? And put them into your... The idea is to have a Word document like this one and include all the answers within, right? In the last one is the interesting one. You need to perform a prediction of 10, 15, 20, and 30 years and show it into a table. I mean, you perform the regression. Afterward, you can perhaps use Excel, create the table, and put the results. However, it's important to include 3 things, please, in the Word document. First, what's the code that you are using? Second, what's the output from the console? This is the console. And 3, in case you have a chart, included as part of the output, right? Those 3 things are important. Why? Because I'll test whatever you are showing me to make sure that actually is true, right? True between quotes. And last but not least, I want your conclusions, your analysis. What did you analyze out of that? What trends did you find? What error did you get? Things like that. Try to get your business approach because I won't limit your creativity. Each and one of you comes from different areas. So your mindset and the way to approach things is different for each and one of you, right? Of course, it will be delivered in teams. It needs to be made in teams and delivered in teams, don't worry. But I really want to get your input as a team, what you found as a team, what are the conclusions that you found out of that, and what are the takeaways that you get out of the entire analysis, because that's the most important piece of your delivery. How are you using the tool, and how are you digesting the information and getting takeaways in front of me to get my buy-in? Crystal clear? Okay. Is there any other questions so far about it? Go for it, Anna.
Yes, thank you. So just to recap, because I think in the first class you told us that if it's in teams, anyways, we still have to upload it, like each of us as a team.
Yeah, actually, this time around.
Not anymore, because we have the teams there, right?
Yeah. No. However, I need to specify in the assignment that it's a group assignment. I think from now onwards, I am specifying that it's let me check assignments. Assignments are here. Let me check because it's something that I need to set up. I think I did, but let me take a look. More options, and the group assignment must be checked. If not, oh my God, this is a group assignment. There you go. Thank you I think no one has submitted anything, but did I call them project groups or business analytics? Project groups, right? Those are called project groups, I think.
It's a business analytics.
Business analytics groups. Beautiful.
Yeah.
There you go. Thank you so much for that. And let me now, with this change, it means that when one of you publish it, it will appear for everybody in the team.
Okay.
Right? But please make sure, if it does not happen, make sure that it appears for you. I mean, either way, if your names are there, no worries. But why is important that your name, that it's assigned to you? Because the feedback that I give it's for someone who actually uploaded the assignment, right? For me, from now onwards, the feedback is very important because I'll let you know how to make it better. I'll let you know what findings I have. I'll let you know what are the good key points that you include as part of that, and also a couple of suggestions or documents or videos about how to make it even better. But it's part of the learning process. It won't affect your final assignment. As long as you complete all this, you'll have the highest grade if you complete it successfully, right? And it's accurate. So, however, the suggestion that I'm gonna make you, not necessarily it will affect your grades. It means what's my suggestion so you can keep on learning even more for this particular topic.
Great, thank you.
My pleasure. Is there any other questions so far?
So the first two assignments, we upload them.
Yeah.
I mean, we did it in Teams, but we upload them separately.
Yes. Yeah.
That's okay, right? Okay.
Yeah, it's right. The first three assignments, you need to upload it individually, but from now onwards, I'll make sure that the group assignment is individual. Actually, for the, you know what? For the third assignment, I think no one has uploaded it yet. So I think we can change it at that fashion as well in order to make it standard from now onwards. So let's do that. Let's standardize it and make sure that it is a Teams assignment. Actually, that one, it's already set up. Teams assignment, there you go. And yeah, I think, never mind. And we said business analytics groups, and there you go. Now, as long as one of your teammates upload it, it will appear for everybody, right? It has happened that some students have told me, Fer, I don't want to do it in teams, I want to do it individually. Has happened. So when that happens is when I change that, take you out of the team and give you a separated grade. I mean, hopefully this is not the case. Why? Because in teams, we're stronger, we are better, and we are more accurate, honestly. I mean, despite I'm a leader in my group, in my company, I ask my key leaders in my group as a proof of concept. What do you think about it? Do you think it's a right approach? Because I'm showing the results as a team, not as an individual. If it were as an individual and I make a mistake, it's my problem, I'm gonna pay for it. But in my company, it's not the same. It is not the same. If I make a mistake, it's a mistake that it's gonna be attached to all my team. And that's not fair. That's why it's important to work in teams and make sure that we have different point of views to solve the same problem. You as a leader must have the capability to grab them up and create a single takeaway out of the different opinions. That's a real challenge. And make sure that the result is gonna be achieved, and also every one of you agree on the solution. Crystal clear? So as you can see in my assignments, I'm trying to test many things. Your criteria, the way that you work in teams, how you make sure that all of you are on the same page and the goals are achieved. That's the main goal here. And in the final assignment, it's much cooler because you need to take decisions together. Questions?
So the team assignments number 3 and 4 till Sunday, right?
Yeah. Actually, I forgot to do that. I was planning, actually, it was a suggestion that to give you a table about when it's expected to be delivered every single assignment. I mean, you know that it's Sundays, but yet I'll create a table and make it available for you. So you know when is the deadline for us for delivering each and one of the assignments.
Right. Thank you.
My pleasure.
I just have
Sure.
another question. I'm sorry.
No, nothing to be sorry about. Go for it.
Bit about what you want on the conclusions for the assignment 4.
Can you please come again?
Do you hear me?
Yeah, loud and clear. But I didn't get exactly what you were talking about. So about the conclusions, what? I'm sorry. Can you please elaborate?
You said something about the conclusions on the assignment 4 that you want something specific, but I didn't catch what you want.
No, I don't want anything specific. That it's open. It's open to you about what you found as the lowest value or what trends you found. I mean, I want you to analyze your results and give me your inputs out of that. I won't bias it. I don't want to force you to answer questions. I want you to use your creativity and try to identify what are the unanswered questions that you can have. And you can give me in your outputs. I'm testing you. I'm testing your experience. I'm testing your capabilities, and also to apply to this. And how would you apply for your own area? Something like that.
Okay, thank you, Professor.
My pleasure. Is there any other questions so far before we wrap it up for the day? Well, if there aren't further questions, thank you so much, everybody. Hopefully today was funnier than other days, because I know that it's challenging to deal with code, deal with all the concepts, and deal with all the mumble jumble that I say, because I talk too much. But hopefully I can put everything together, give you a powerful idea, a powerful tool that you can use on your daily basis or for decision taking, because the idea here is to give you tools that you can take smarter, faster, and more accurate decisions. So looking forward to keep on hearing from you. See you next class. Thank you so much, everybody. Have a wonderful evening. It's been a pleasure. Enjoy and enjoy your class. That's the main thing. Thank you so much.
Thank you.
Thank you, Professor.
Thank you.
Bye.
Thank you, Professor. Bye.
Bye. Have a good
Take
night.
care. Have a good night. Take care.
Thank you, Professor. Have a good night.
It's my